So, yep, how was the last week? Is everything fine? So, can you hear me? Okay, good. So, let's see. I'm expecting, yep, the another instructor, Minsang. Okay, so let's wait maybe, yeah, one more minute. Mm, Okay, so yeah, let's get started. So in the past weeks, and then we studied about some kind of basics of Python, and then we also studied about what is object detection, and then yeah, of course we went really fast, but well, at least so wait a second. So maybe link has some issues maybe. Okay. So maybe the link, has been changed. Yeah, so I just want to summarize because we have some new member here, right? So who are the new member? Hi, Minsang. So
Hello, Professor.
yeah, hi. So the who are the new member here?
I'm a new one.
Okay, you are the only one?
Uh, I think so.
Right. Sounds good. And then do you know where are the lecture notes?
Yes. They sent it to me through email.
Okay. All right, sounds good. All right, so in the past, and then we studied about, what is object detection, and then some kind of basic concept, and then the Juyong and provide, some tutorials. And well, that is really simple. The case of object detection. So the example was to detect, the cats. All right. And then for some student, and then it looks pretty challenging. But I think that is a really wonderful the example. It has all the necessary kind of component. All right. So definitely, and then using that example, that tutorial, and then well, you will study and how to detect some object, all the necessary steps. But that is a little bit really simple example. And then what we really want to do in the real project, and we want to participate in the hackathon. And then the theme of the hackathon is, yep, we want to detect the load damages. So we have whole bunch of the images, of the load surface, and then well, you are supposed to detect some specific type of the load damage that is in a pothole. Okay, and I think let me see. Yeah, so well, if possible, and then turn on the camera. So we're gonna form in a team in today. So definitely you want to see who gonna be your the teammate. Mm, and also when I share this one, okay, can you see? this hackathon information? Yes?
Yes.
Okay. All right. So, and then, well, I think, all of you already, registered for the hackathon. Am I right? And then it means, and then you saw this webpage. So, yep, the hackathon is scheduled at the USC main campus on the day July 26th. It's a whole day hackathon from 9 a.m. to 9 p.m. And then, I'm encouraging the student start, the competition as early as possible. And we have two different groups, the high school groups and then college and above, group. And then if you click the high school part, and there's just some simple the descriptions. Yep, we want to detect potholes, and then this is a team effort. So you are supposed to form a team and then provide the solutions. So basically the mission is using the knowledge, and then we studied in the class, and you are supposed to build an object detection model. So we studied YOLO. So, you can use in YOLO. And especially from some specific type of load damage, the potholes. All right. For that purpose, and then we have training stage, and then testing stage, then actual inference stage. So we will provide training data set and then test data set with all the labels. So using those training data set and then using YOLO, and you are supposed to build a model. And using the test data set, and you are supposed to evaluate the performance of your model. That is basically the accuracy. All right. So that is the first goal. All right. Try to create any kind of working model. Accuracy is not really important. And then, I want to see at least some kind of working the model. So it means you understand all the steps. All right. But this is a hackathon and this is the competition. So once you know that your model is working in any sense, then you should check the accuracy and then try to enhance the accuracy. All right. And there are some way, to enhance the accuracy of detection model. And some are quite straightforward or some are quite tricky. And then from now on, and then you're gonna search for the web, and then you need to find your own way to upgrade the performance. And on the hackathon day, and then after you are submitting and your model, that is the code, and then some brief description about the code, and we have separate the hidden test data set. And then using the hidden test data set, we're going to learn your model and we will generate the accuracy. And then using that accuracy, we are comparing with all other models, and then we will decide who is winning. Okay? So the high school student, and then you are competing with other high school student. So, maybe not that many, high school students are participating. And then the college and above level, we have many students there, and then they are competing for some different problem. The data set is pretty similar, but the college and above their level, and then they are detecting load damage, the multiple types of load damage, and then not just detecting, and then they need to classify what kind of damage it is. And then the same thing, they're gonna evaluate the accuracy with some kind of hidden the data set. And then based on the accuracy, we can decide who's the winner. So, basically, the object detection, the steps is pretty same. All right. What kind of object you want to detect from the images? Simple one, complex one, the basic approach is all identical. So once you know how to detect any kind of object, then later you can apply the same thing for detecting many other different types of objects. All right. Then again, in AI, to understand the real world, and then, well, visual, the cognition is quite important. And then through this kind of object detection, yeah, the AI try to understand the real world. Okay? So object detection is a very fundamental and then essential kind of techniques for AI. All right. So in the previous the lecture, and we studied about the really simple tutorial, and then with some small amount of data set, that is the images of cats, and then everything is labeled, and then while Juyeon provides some simple tutorial. Okay, now and then I just want to ask how many of you are really following that tutorial? Did you try? And then anybody success? Yeah, don't be shy, just I'm asking. Yeah, someone says yes. Okay. So tried it. Okay. Then did you succeed or not? What's the meaning of I tried? Okay. Someone tried and then got some errors and then yeah, somewhat confused. Okay. And then well, okay. Yeah, that's okay. Yeah, but today and well, yeah, we have Minsang, and Minsang gonna help you. And then I just want to check the every steps. All right. So maybe after today, and then at least you should be able to learn this simple example. Okay. So I just prepared the really, the basic information because I just want to check step by step, even from the first one. So let's see. Can you see this slide? Okay. So this is absolutely the beginner's guide. The purpose is I just want to check each step. So yeah, basically this is object detection, and then I think everybody knows this at least now. And then the first step, I just even check Python. The Python is correctly installed on your computer. I need your confirmation. All right. Okay, so later maybe Christina and then Minsang, yeah, can you check each the students one by one? All right. Okay. The first step is definitely the installing the Python, and then so even you need to check the version of the Python, and then well we want to install the latest stable the version. So maybe two recent one, and then it's not really confirmed. It's not really recommended. All right. So right now in the version 3.12 or 3.13, and those are the stable version. Okay. And then yeah, here, yeah, we can verify the installation. So you can simply type this command, the Python and the version, and then yeah, you can see in the version. All right. Next, the installing the Jupyter notebook and then some other tools. So basically it's pretty simple, and then open the terminal and then just type pip install Jupyter. So anybody has some issues in Jupyter? again, yeah, we need to check one by one. All right. The later, don't say, oh, I don't know how to use Jupyter. Okay. This is the chance. Yeah, again, the Christian and Minsang, and please check. Everybody has Jupyter. All right. And then also, yeah, we're gonna use YOLO. Okay. And then YOLO, and then it's a kind of the packages in Python, and then you need to install. All right. So the something like this, yeah, pip, and pip is the command in Python, right, to install some kind of packages, and then install Ultralytics, and then this is the company name, all right, who is providing the YOLO. So in this way, yep, you have Jupyter, and then you have YOLO. Okay. And then after that, in the launch the Jupyter notebook, all right. And then, yeah, you can create in a new notebook, and then you can program, or you can copy and paste. So the tutorial. And then when you copy and paste, yeah, don't try to copy the entire file and then paste and then learn it. The good thing about Jupyter, yeah, well, you can just copy line by line, and then you can execute line by line. And you can immediately check if individual line is working fine or not. All right. Okay. And then, yeah, Krishna also provided some kind of, the videos. And then, well, it just show, yeah, some, how to execute, the programs, right? So after that, well, still, we need some more, the libraries. So yeah, we installed the package, the module, Ultralytics, and then well, we don't need to import everything. So we just select only YOLO. So yeah, you can just put this kind of the command from Ultralytics import YOLO. Then now and then in your program, yep, you have YOLO. And you can do some other things. So for example, well, many times in machine learning, because it requires lots of computing power, and then while we are using GPU, but while your computers and then laptops usually does not have any GPU. But at least you need to know if how actually you can check if your computer has GPU or not. It's helpful. And then again, the file management is also quite important. So how to read the input data, and that is one of the most important thing, right? And then you need to understand the path issues, the location of folders, and then what kind of input data you have to read. In our case, not just image data, and we also need to read the labels, right? And then well, sometimes we need to read the files individually, or there's some better way. So for example, we have some specific data format like YAML, and then if you create YAML file, and you can put all those the location information of input data and the labels and what kind of class you are doing considering. And then, to use the YOLO, and then, we need to import something called PyTorch, and then this is a very popular kind of deep learning framework. This one is providing lots of tools for machine learning. All right, and then this is a kind of essential for executing the YOLO algorithms. Of course, well, there are many different ways, but well, this is one way. And yeah, Yeah, using this kind of command in Python, you can easily check if your computer has GPU or not. So this one is specifically to check the NVIDIA, the GPU. Then maybe you don't have it, right? But when you run this one in Colab, then well, the Colab has GPU, so you can have some different, the result. All right. After that, yep, you are ready to program. All right. But this is a machine learning, and then well, the machine learning means we are learning from the data. So we need to prepare the data. To prepare the data, and then well, first thing, you need to know the location of data. You have to remember that clearly. So in general, we are creating some folders, something like this. So for example, data set is a kind of big folder, and we have subfolders like images. That is the actual images. And then, well, if you recall the, object detection training, and we have training data, and we have validation data, we have test data separately. So usually we just create subfolders, and then well, we just put the corresponding the images and the data. So for example, data set images and train. It means, apparently we are putting the images for training. The data set images and then via valuation, then this is for the test data, for example. And then well, we can have separate, the folders for labels. All right. So rather than put everything in one folder, so we'd better have some kind of organized way to understand where are what kind of data. Okay. So that is kind of important. And then the good convention is the image name and then the label name. Yeah, you'd better have the same one. That is more convenient. So for example, the image name is car.jpg, and well, the labels for this specific image, and you can have car.txt because label itself is a text file. And you prepare the data and then locations. The next thing is, you need to provide the labels. So for example, if this is a cat detection and from the images, and you need to identify cat object and then provide some kind of appropriate bounding box. And then you need to say, okay, inside that bounding box, the object cat exists. That is a kind of logical discussion. But actual things, we are using some specific tools, software packages for that purpose. So basically it means, these software packages, you are reading some specific image, and then you can draw some bounding box, and you can provide some labels, and then this package can generate the label data. All right? And usually this process takes lots of time. Just think about it when you have 10,000 images. So you need to see 10,000 images first, and you need to identify some object. You need to create some bounding box, not too big, not too small, and then really appropriately covering the object. And then you need to provide the class. But in the project, okay, this is too much time consuming, so we will provide the labeled the data. And then all the participants in the hackathon, and they wanna use the labeled data. So it's fair, all right? But at least you need to understand, if you want to do object detection for your own purpose, you need to go through this step, all right? And then there are lots of different software packages, and they all can create, the labels. So once you using some graphical user interface, and then you can make some bounding box and then provide them the class. But actually, the package is gonna create, that kind of location information, something like this. So you have class ID. It means what kind of class this is. So for example, cat. All right. And then the x-axis center point, y-axis center point, and the width and height, something like this. So we know, okay, this is the box, and we know the location of the box in an image. Basically, any kind of digital images, and then we are using the concept of pixels, right? So on the width, and we have some number of pixels. In the height, we have some number of pixels. It's like some kind of Cartesian, the space in 2D. All right. Okay. And then, many times, when you use some kind of an absolute numbers, and then it's not really convenient because the image size can be different. Like some images, and then the height is 480, the width is 640, and some images, the resolution is different, right? So it's confusing. So many times, we are using normalized value between 0 and 1. All right, that is way more convenient. So these are saved in the text file, with the same name as the images. All right, but still in YOLO, and then using that kind of individual the images and then individual labels, and then it's quite tedious and then confusing. So and then we have some kind of special the format called YAML, yet another markup language. This is a kind of text file, again the human readable data. And then it just provide some kind of information about data storage and then data exchange the format. So usually, and then in computer science, and we are using this kind of the files to represent some configurations or data exchange or some kind of metadata. So in the YOLO, and then data dot in YAML, and then YOLO is reading this one and then try to understand where are the data set. So for example, this is the example content, and then Jiyoung already showed the YAML file for cat detection, but the general format is this. So we need to know the location of the data. So this is the path to the folder. And then, we have training data set and the validation data set. It has subfolder on the data set. We need to show the exact location. And then we need to say what is the number of classes. So in the cat detection example, and then we are detecting only one object, right? Cat. So the number of classes is just one. And then name means, we need to provide the name of the object, something like, cat. For the load damage, and then still, you are supposed to detect only one object type, that is Pato. Then when you construct this kind of, YAML file, then the number of classes is still one, and the name is Pato. For college and above the group, and then they are supposed to detect 4 different classes, 4 different types of load damages. So then the number of classes is going to be 4, and then the names, you need to provide 4 different names of load damages. All right. So now and then we are ready. Okay. So all the software is already installed, and then the location of data, YOLO knows that. And the labels is already prepared. The next step is, how actually we can train. Okay? So it's pretty simple. So, well, the main, part is, calling this kind of in YOLO, because you already, let me see. I don't know. So, calling YOLO, and then you need to select what kind of, the model. So YOLO has lots of different versions. YOLO version 3, YOLO version 5, YOLO version 8, YOLO version 10, YOLO version 11. All right? The bigger number means more recent one. Yeah, the more recent one may have some issues. It's not completely proven. So maybe, you can use version 8, and then it's quite stable. And then also, each version, something called the size. Nano size, and then the small size, and the large size, extra large. What does it mean? So what kind of efforts we can put in developing the model? So deep learning, and if you understand the concept of deep learning, and then when you are learning training, and then there are lots of different levels, and then when you introduce more levels, then we say that it's deeper. When you introduce more number of levels, then the model size is going to be bigger. It means it requires more computing resources, more computations, and then bigger program. All right? And then training time going to be much longer. So expensive, the learning. What's a good thing in general? Probably the accuracy going to be higher when you use bigger the model. Yeah, but here, let's use smallest one, nano. Why? The whole point here is, we just want to check, our program is working. The result is not really important now, all right? So with some kind of minimum effort, and then we just want to create any kind of working model. So we can select the nano and represent nano, right? The smallest, the model. Then later, if you want to enhance the accuracy, maybe you can try the different, the size. All right. And then now, and then model equals in YOLO means, and then you just say that, I'm trying to use YOLO version 8 nano size. But the training doesn't start yet. So you need to call model.train. And this is the real command, okay? Using the data and using the algorithm, generate the model, build a model. So in order to build, the algorithm is already selected here, but for the training, you need to provide the data. Where is the information? Data.yaml, right? And you have some other parameters like the image size and then epochs. To understand the epochs, and then you need to understand how the deep learning is working. Basically, in deep learning, we are using the same training data in order to learn. But we can repeat the same process multiple times for better learning. Okay? Epoch training means right now, and you can think, okay, using the same data set, the same amount of data, and we are repeating 20 times, all right, for better learning. So in general, too small number of epochs, then accuracy is not that good, all right? While you are repeating, the accuracy is increasing, but after some number of iteration, even though you are increasing the epochs, it doesn't affect the accuracy much. All right? So it's something like convergence. So we need to stop there. But anyhow, that kind of thing, and then later, you're gonna study, and then maybe you can play with this kind of epoch number for the competition. But now, give some, reasonable number like 10, 20, something like that. All right, the image size is the same thing. All right. Then now, this one is running for a while, and then it's gonna generate result. What is the result? The program. Something called model. And then this is the program to detect the actual object. All right. So building model, and then that is this much simple. Okay. And then I'm emphasizing that a lot. Building any model, that is pretty straightforward because we have wonderful tools and the libraries and packages, right? So when you call model train, internally, so many things are going on, all right? Very complex, the program is being executed, but you don't need to know that, all right? It's a black box approach. All right, after creating the model, you're not done yet. Why? The whole purpose is not creating any kind of model. And then the real purpose is, we want to create a good model, right? The next question is, how do we know which model is good? So we need to discuss. We should be able to discuss that one. So we need to evaluate the model performance. Yep. After creating the model, and then you can just call model.val. Then this one is creating some numbers. Based on what? Your training. So this can be called as, actually, this one is, there are two different kind of, the evaluation and accuracy. You can generate accuracy using training data set. It is called training time accuracy. You can also generate, these metrics using what? Test data, validation data, right? That is kind of testing time accuracy. And then because, the training data set and the test data set, they are different. Even though you have the same model, and then the performance can be different. All right? So you should be able to understand, this accuracy if you want to enhance the performance. Okay, that can be discussed in later. All right? For now, and again, the whole purpose is, you should be able to create one model, any model, all right? And you need to understand, okay, the accuracy. All right. Now we have accuracy. So let's assume that, the accuracy is reasonably good. Maybe 70% accurate or 80% accurate. All right? Then now, and then you can use this, the program for the prediction. It means you just get some new image without any labels. All right? And then you just provide the new image as an input of your model, and your model is reading the image and then generate the result. Okay? That is called prediction. All right? And then if this prediction is correct, then we can say that, oh, your model is good. we can use your model in practice. All right. So always, if you really care about the performance, and then you need to think about the training time accuracy, the test time accuracy, and the accuracy in the real application in reality. All right. So what if when you train, the accuracy is pretty high, but when you apply in real life, and suddenly accuracy is not that good? Then what happened? Oh, something is wrong, right? Maybe you need to retrain. There are many different reasons. Maybe data preparation was not that good. Maybe algorithm was not that good. There are so many reasons. So once we have this kind of prediction, and if we can create, some, metrics and the accuracy, then we are done. In hackathon, yep, using up to this point, and then you are supposed to create all this, and then you submit the code. Then we have, yep, some hidden data set, and using that, yep, we are making the prediction using your program, and we're going to evaluate the accuracy. Is it clear? Okay, everybody, is it clear? Good. So now I think you have some conceptual understanding of all these steps. And then there are some tips and then troubleshooting. So usually, don't try to use the entire data set from the very beginning. Of course, our task here is pretty small number of data set, so we can use all of them, right? But in reality, what if you have, a tenth of thousand images? Don't try to use all of them, because it's gonna take lots of time, and then, it requires huge amount of computing power. Computing power means what? Money. All right? You are wasting money. So usually, and then while we are sample, from the training data set, and then using the sampled, data, and we are just checking the feasibility. Okay. Yeah. Somebody asked, where could I, revisit the slide afterward? Now, of course, I'm gonna put, everything in the lecture note, folder, shared folder. So, and then, yep. So using a small, data set, and then just check the feasibility. And then if you think, well, your approach is working fine, and then later you can use, more amount of data, and then perform the training. And if possible, and then use, GPU, because, machine learning, especially the, image machine learning, it requires lots of computing power. It takes lots of time when you use only CPU. So your computer does not have any GPU. So that's why, well, we are recommending, using Google Colab. And then this is a free service. And then, the Colab is a kind of hosted in a Jupyter Notebook service, and it does not require any setups. And then you can use it free of charge. And then you can use lots of, the computing resources, including GPUs. All right, especially for machine learning, data science. Yep. This sometimes Google is doing really good things. And well, it doesn't mean, and you can use huge amount of computing power, because they have some kind of cap. All right. For some certain amount of computation, you can use Google and Colab, I mean. But if your job is really big, the Colab doesn't work, or it takes lots of time. Minsang, am I right? Mhm. So, uh, Well, they are providing some kind of paid version of Collab, or everything is just, the free.
I don't think they tried the paying version. I think they only try with the free version, but it takes several days,
Mhm.
even worse. So yeah.
So for really big jobs, and then well, because it's a free version, it takes lots of time. But well, our case, and then well, we are doing some small kind of machine learning, small amount of data. So and then I think the collab is enough. So based on your experience in the meantime, so when you have maybe 1,000 images and 2,000 images, and then applying YOLO, especially Nano, it doesn't take, well, hours and hours, right? Yeah. One just, building the model, it can be done maybe several minutes in something like that.
Yeah, it's gonna take.
Mm. Well, but in the real world, and then sometimes, we are using the lots of, the images. Sometimes millions of images, like in a Tesla. And then the amount of computing power is gigantic, actually. All right. So definitely, I recommend to use, Collab. All right. But today, and then our whole purpose is, well, following the Juyong's tutorial, and then you are supposed to execute line by line, and then just confirm everything is working on your computer by your hands. All right. And well, maybe Krishna and then Minsang, and you're gonna, help the student. Is it clear? All right. So we're gonna have a 10-minute break. So after the break, and then you need to open your computers, and then you need to share your screen with, Minsang and then Krishna, and then you are supposed to show. All right?
Professor, do you want me to create breakout rooms just so that we
Yeah.
can, yeah?
Mhm.
Okay.
So I'm gonna create, the break rooms definitely. And then there are two different ways. So maybe I can create, some kind of private room, and then maybe Minsang and then you can visit the student one by one. Or let's form a team first. And for each team, and we can create the separate break room, and then well, everybody can share the steps. I don't know. During the break time, just think about it. Which approach is better? All right. Okay, 10-minute break, and then we will meet at 8 p.m. Okay, it's 8 o'clock. All right, so please, turn on your camera. Oops. All right, so did you think about, what can be the better approach? And form a team first, or just, making some individual rooms?
I was thinking,
Mm.
how about we have the kids who need help launching the programs like Python, Jupyter Notebook, and Colab if they need help with that. I can be that room, breakout room, and then Minsang teacher can help with the kids who already have everything downloaded and then make sure they know how to do all the YOLO stuff. Is that okay?
So you mean basically making two rooms?
Yeah.
And the phone is more fundamental things.
Mm-hmm.
Then the other one is, more like the actual object detection part.
Yeah.
Okay. All right. So then we are creating two rooms, and then room one is more fundamental, the basic things, and then Krishna gonna help. And then room two is about the actual object detection part, and Minsang can help you. All right. Okay. Good. So I'm gonna create two, and then participant, you're gonna choose the room, create. Okay, doc. All right. It's done. Yeah, please go to one of the room. So, and then Ms. You can see, well, what others are doing. All right. And Minsan, you go to room 2.
Yeah, I was thinking like all students are in room 1 right now. So maybe I
Everybody
can,
quit.
yeah, I can help Christina to before.
Okay. So
Okay.
then, oh, all right. And then
I'll figure out if they actually need the help or not.
hmm
The
Wait, sorry, are we going to room 1 if we already have, if we don't have Jupyter and Python downloaded?
Yeah, so if you
Yeah.
don't know about that, then go to room 1.
And then if we already have it downloaded, just go to room 2?
Yeah,
If
so
you
if
have
you
question, yeah.
yeah, if you know how to use Jupyter, and then if you are more interested in learning the object detection code, and go to room 2,
Mhm.
and Minsan can help you.
Okay, thank you.
Okay.
Professor, can you
Okay.
create one more breakout room for us?
Okay. So let's see. How actually I can add break room. Wait a second. Hmm. Option. Actually, I don't know, how to add the new room,
Oh,
but I will try. So I'm gonna create, 3 break rooms. So I'm not sure, if this gonna affect the existing rooms or not.
okay.
Uh-uh. Uh, so the only way is I need to close the existing rooms.
Oh, okay.
I need to create, again.
Okay.
So you wanna meet some student?
Yeah, I'm helping Julia setting up the
Oh.
Jupyter notebook.
So you can do here.
Okay.
Mhm.
If that's okay. Right. Okay. Tell me about your situation right now.
So like since I have to like download like the 2 things that we have to download, I've tried doing it with Christina, but it just like doesn't work. Like
Mm-hmm.
it says like there's an error or something. It just like does
Mhm.
not work. So we just
Yeah,
don't know how to.
can you share your screen for me?
Yeah.
Okay. What steps are you so far?
I
You down
downloaded Python and
Mhm.
I went to like environment because she told me to.
Uh-huh.
And it's just that Python is not downloaded in there, like, but I downloaded it.
Let's see. You might have to manually add them. Mm.
Yeah.
You can download in a Python installer. So when you execute the installer and then you can just guide in. So can you go to the web page? Yeah, the Python web page. Yep. So here and then you can select, for example, Windows. Yep. And then there's an installer. So wait. Go back. Yep. So you need to select one of them. So if you want to download the version 3.13, let me see which one is better. Can you go down? So Minsang, and which one gonna be better? Any kind of thing, right? 3.13.
Yeah.
And then are you using Windows machine?
Yeah.
So then just click download Windows installer 64-bit. Yeah, something like that. Click it. Okay, so it's downloading. And now it's downloading. Almost there. Okay. So then double click it. Yep, install now. Set up failed. No more issues cause you set up. Oh, another version of this product is already installed. So it means you have the Python, right?
Yeah. But
Okay, then if you have in a Python, then you don't need to download, right?
yeah, but it's just like not popping up here because
What is this?
Mm.
So it means you don't know how to execute in Python?
yeah, because like I'm new to this because my mom wanted me to do this.
So I think she had a problem doing the pip in the commands, and then that was because there was no path directed, right?
Mm-hmm.
Then that way she had a problem downloading the Jupyter Notebook through command line. So have you tried downloading it through the the website I had told you before? Anaconda way?
I don't think so.
Okay. Let's see about that one first. Mm. Mm. So how far have you tried with the Christina's the YouTube one?
She didn't show me the video, so
Oh, okay.
it just like doesn't work.
Mm. Mm. Organism. Mm. Okay. Can you try Python on your command prompt? Can you try Python dash dash version instead of the Python 3? Just Python space Python space dash dash version. And
Just Python. And can you also type in just where space Python? Okay, so that is the location of Python.
looks like I have a version. Microsoft.
That is the default location. Minsan, can you check in with your computer?
Mine is different. I
Yeah.
have a local
Mhm.
one, but it says Microsoft window apps over there.
Yeah,
I'm
so
not so sure
the
how-
location is weird.
Yeah.
So, mm,
see. Maybe we need to uninstall that one, and then try to install.
maybe that is another way, yeah.
um, window apps. Microsoft app data. Mm. Okay, let's try looking. Okay, there is something installed. Can you open file location for me? The Python 3.13.
Could you say that again?
Can you on the apps over there? There's a Python 3.13 64 bits. Can you open the file location? No, the search that you have right now. Yeah. Type Python there. Yeah. Right click that one. Or the arrow on the right.
Yeah. No, not that one.
Yeah, so it is. Okay. In that case, let's try typing control panel in your search. Click on that and see programs. Where do we go? Programs and features. Let's see. Let's try to find Python here. I think your screen froze. Yeah, okay. Try finding Python there. Scroll down. Okay, let's try to uninstall that. Click on it.
This one?
Yep, that one. Uninstall. Up there. You can close that Python 3.13 over there. Comments looking like, yeah, that we can close down.
Yeah, maybe you can wait the on installation, and then well, maybe later you can install it again. Oh, it's done.
Okay.
Okay, so can you quickly try the installation again?
You can close it for close that. Let's try to see. Try command. Open up the command prompt again, and try where Python again.
It's
Okay,
still there.
so they're still there. Okay. Um.
Okay, so maybe yeah, later, and then maybe you'd better meet the Christina, and then working with Christina about this issue. So we need to conclude today's the lecture. Okay.
Okay.
So how are things going? So anybody successfully building the model? Nobody? And then Lion, are you not in learning? So are you done? Yeah, please, let me know. Anybody was successful in, executing the Juyong's tutorial? Nobody? And then, well, what was the step? Until, which stage, you are successfully executing the program? Oh, come on, I need feedback. If you're not saying anything, then I don't know what to do.
I think I pretty much had everything working.
Okay, everything's working. So, one person, and then another. Oh, very close.
I have an error right now, but I think I can be done really soon if I just like fix this.
All right. Yeah, because the reason why I'm asking is, we need to form a team, teams, right? And then, well, we need some kind of leaders. And then leaders should be, more knowledgeable, actually, at least in the Python. All right. So I think, we have around 10, 11 students. So maybe form 3 teams and then they're gonna be, the best. So any volunteers for team leaders?
I
No,
think
not really.
I think Ray should do it. I know you
Who?
were in the program last year.
Who?
I think Ray should not. I
Okay.
nominate Ray. Yeah. What do you think, Ray?
Ray?
Are you okay?
Sure, yeah.
Yeah. Okay.
Okay. Raise one. Anyone? Any other? Sarah, can you?
I keep getting like a bunch of errors in my code. I just don't know if I'm like confident enough to be the leader here right now.
Yeah, but well, nobody's volunteering. Or do you wanna think a little more? Try some more, and then we can decide next time.
Yeah, I think that'd be great.
But promise, and then don't just sit down, and then you need to make lots of errors, and then try to solve the errors. All right, and well, you need to figure it out. All right, and if you have any questions, then ask. Okay. Yep, that is a kind of must. And then, well, I'm gonna also release the data set for the real hackathon, and then another tutorial for the hackathon. All right. So following the simpler version, Juyong's tutorial first, and then after that, if you have time, like in array, and then you can try the tutorial. Okay. All right. So.
And then I had a question.
Mhm.
I was wondering for the hackathon itself, should the kids use Google Colab or should they use Jupyter Notebook?
So, yeah, you can, using Google Colab, and then you need to use, the Jupyter Notebook. All right. So
So
it's
use
the
both?
tide. All right. So you are talking about, using Google Colab or using your own machine, laptop. Am I right?
Yeah.
Yeah, both are possible, but using Colab and then, well, you can use GPU. It can be faster.
Okay.
Otherwise, and then if you're using your laptop, maybe you need to wait longer.
Okay.
Yeah. Other than speed, and then it's the same thing.
And then I think Samuel said he wants to volunteer as a leader.
Okay.
Mm-hmm.
Okay. Yeah, but well, we decide, next week, and then we will decide the teams. But well, I'm gonna remember, these volunteers. So definitely, and then you have to try. And when you have issues, don't just sit down, okay? We want to learn something, so we need to talk, to learn. All right? Okay, all right, thank you. And then, well, we will meet next week.
Thank you.
Okay.
Thank you.
Good night.
Thank you. Thank you.
Thank you.